Okay, in this problem, we are given the percentage of the sample, which is potassium bitartrate, and or that is the cream of tartar. So it has been taken for analysis, which involves the following data. So the amount used for titration is 30.06. So take note that this cream of tartar is in acidic form. So we are going to titrate it with sodium hydroxide, which is 30.06%. However, again, there was an overrun again in the endpoint. So there was an excess, or it was overstep. So we have to back titrate it with sulfuric acid, which is 0.50 ml. The normality of sulfuric acid is not given. However, we are given this analysis again, previous analysis. From previous titration, it was analyzed that in 1 ml of sulfuric acid is equivalent to this value means equivalent to 0.02550 grams of calcium carbonate. So from this data, we can calculate the normality of sulfuric acid. And another 1 ml of sulfuric acid is equivalent to, this is a concentration ratio, 1 ml of sulfuric acid is equivalent to 1.20 ml of sodium hydroxide. Okay, so again, we make use of the data or formula milliequivalence of the acid is equal to milliequivalence of the base. So the easiest way to calculate the normality of sulfuric acid would be this. Milliequivalence of the acid, which is milliequivalence of sulfuric acid, is equal to milliequivalence of calcium carbonate. Okay, our objective is to determine the normality of sulfuric acid. So we make use of the formula normality times the volume. We're given the volume of sulfuric acid. We are given the weight of calcium carbonate. So we make use of the formula weight calcium carbonate because we know the weight, we do not know the volume. So we make use of this formula. Molecular weight of calcium carbonate divided by the factor times 1,000. So our objective is to determine the normality of sulfuric acid. Okay. So normality now of sulfuric acid times the volume, which is 1.0 ml, is equal to the weight of calcium carbonate 0.02550 grams divided by the molecular weight of calcium carbonate, which is 100.09 grams or 0.0 grams, divided by the factor. What is the factor of calcium carbonate? Take note that the charge of calcium is +2, carbonate is -2. So +2 times 1 for the subscript, the factor is 2, equivalents per mole times 1,000. Okay, so you will get here a value for the normality of sulfuric acid, which is equal to 0.5095 normal. Okay. Now, we need to determine as well the normality of sodium hydroxide because we are only given here the volume. So again, milliequivalence, we make use of the next data. Milliequivalence of sulfuric acid is equal to milliequivalence of NaOH. So this would be normality times volume since you are given the volume and we have already computed the normality. So we can make use of this formula is equal to normality times volume of NaOH. Okay. So the normality is equal to 0.5095 normal times the volume of 1 ml is equivalent to normality, which is unknown, times the volume of so sodium hydroxide, which is 1.20 ml. And you can get a value of normality of sodium hydroxide, which is equivalent to 0.4496 normal. Now, how are we going to determine the weight of potassium or cream of tartar or potassium bitartrate? So, we make use of this formula, milliequivalents of potassium bitartrate, cream of tartar, plus the one that we have used in back titration, milliequivalents of sulfuric acid, or as I've said a while back, you can write it on the other side to get the net milliequivalents is equal to milliequivalents of NaOH or milliequivalents of KHC4H4O6 is equal to milliequivalents of NaOH minus milliequivalents of H2SO4. This is another approach. So this would be the net milliequivalents. So this is the net milliequivalents. Now, okay, so we make use of this formula, or you can again make use of the first formula. So you place the the sulfuric acid, milliequivalents of sulfuric acid here. The weight now is equal to our unknown. So that is weight is equal to our unknown times factor. So simplifying, what is the factor of potassium bitartrate? We have 1 rep as an acid. It will act as an acid, 1 replaceable hydrogen ion. So the factor is 1. Okay, so times 1 equivalents per mole times 1,000 milliequivalents per equivalence. So you can now simplify, divided by the molecular weight of potassium bitartrate, 188.18 grams per mole is equal now to 0.4996, which we have solved a while back, 4996 normal, times the volume of NaOH used for titration, 30.06 ml, minus the normality of sulfuric acid, 0.5095 normal, times the volume of sulfuric acid used for back titration, 0.50 ml. Okay, so you can get here now a value of the weight of Rochelle salt or potassium bitartrate, potassium bitartrate or cream of tartar, H4O6, which is equal to 2.77 grams. Our objective is to determine the weight of the sample. So percentage of purity is equal to the weight of potassium tartrate divided by weight of the sample times 100. So we are given the percentage purity, which is 97.60%, is equal to 2.77 grams divided by weight of the sample times 100. And you will get here a value which is equal to, so the weight of the sample would be equal to 2.846. Please double check the values. 2.846 grams. So this would be the value.